Problem 14-03018. If n is an odd integer greater than 4, then the first n digits in the decimal representation of the number, open parentheses, n plus the square root of open parentheses, n squared plus 1, close parentheses, raised to the power n, minus the floor of that same quantity, are all zeros. That is, the number, open parentheses, n plus square root of n squared plus 1, close parentheses, to the power n, minus, floor of open parentheses, n plus square root of n squared plus 1, close parentheses, to the power n, starts with n zeros after the decimal point. This is problem 3.11 from Pavle Mladenović's book, Combinatorics, a problem-based approach, published by Springer in 2019.
Solution. Step 1. Define x and y. Let x equals n plus the square root of n squared, and y equals n minus the square root of n squared plus 1. So x and y are conjugates. Their product is x times y equals, open parentheses, n plus square root of n squared plus 1, close parentheses, times, open parentheses, n minus square root of n squared plus 1, close parentheses, which equals n squared minus open parentheses, n squared plus 1, close parentheses, which simplifies to -1.
Step 2. Express x to the power n using its conjugate. Now consider x to the power n plus y to the power n. Since x times y equals -1, we can say y equals -1 divided by x. So y to the power n equals, open parentheses, -1 divided by x, close parentheses, to the power n, which equals -1 to the power n divided by x to the power n.
Since n is odd, -1 to the power n is -1. Therefore, y to the power n equals -1 divided by x to the power n. Now, x to the power n plus y to the power n equals x to the power n minus 1 divided by x to the power n.
Step 3. Justify that x to the n plus y to the n is an integer. We observe that x satisfies the quadratic equation x squared minus 2nx minus 1 equals 0. Similarly, y satisfies the equation y squared minus 2ny minus 1 equals 0. From this, we can derive the recurrence x to the n equals 2n times x to the power n minus 1 plus x to the power n minus 2, and the same for y. Y to the n equals 2n times y to the power n minus 1 plus y to the power n minus 2. Now, define the sequence a sub n equals x to the n plus y to the n. Then, this sequence satisfies the recurrence a sub n equals 2n times a sub n minus 1 plus a sub n minus 2. With initial values, a sub 0 equals 2, a sub 1 equals 2n. Since the recurrence uses only integers and starts with integers, all terms a sub n are integers. Therefore, x to the power n plus y to the power n is an integer.
Step 4. Analyze x to the n plus y to the n. Since x to the power n plus y to the power n is an integer, let's call it k. So we have x to the power n minus 1 divided by x to the power n equals k. This implies
x to the power n equals k plus 1 divided by x to the power n.
Step 5. Determine the fractional part of x to the n. The fractional part of x to the power n is x to the power n minus the floor of x to the power n. That equals k plus 1 divided by x to the power n minus the floor of k plus 1 divided by x to the power n. Since k is an integer and 1 divided by x to the power n is between 0 and 1,
Step 6. Estimate 1 divided by x to the power n. Now, look at the value of x. X equals n plus square root of n squared plus 1. This is greater than 2n, which is at least 10 when n is greater than or equal to 5. So, x is greater than 10. Therefore, 1 divided by x to the power n is less than 1 divided by 10 to the power n. That is, the fractional part of x to the power n is less than 1 over 10 to the n.
Conclusion. So, for any odd integer n greater than 4, the first n digits after the decimal point in the number x to the power n minus floor of x to the power n are all zeros. That is, open parentheses, n plus square root of n squared plus 1, close parentheses, to the power n minus the floor of that same expression has exactly n zeros after the decimal point before the first non-zero digit.
If you liked this video, please like the video to support this channel. Please subscribe to the channel by clicking the subscribe button so you can see other videos. If you have any suggestions, please comment. Thank you.